Hello everyone, welcome back. This is Calculus 2. So in this video, we are going to talk about 2.4 arc length of curve and surface area. So in chapter 1 to 3, so far in Calculus 2, we've been talking about a variety of benefit of using integral, right? So if you remember, chapter 1 and 3, we talked about how to find out the area by using the integral concept. In chapter 2, we were able to find out the volume by using the integral symbol in Calculus 2. What we're going to do in 2.4, we can find out more information using the integral. So the concept that we are going to introduce, we can also find out the length and surface area utilizing the integral. So it helps us to find out many information such as area, volume, length, and surface area, and I will introduce more. So as you see that integral is a great and powerful tool. So let me introduce how to find out the arc length by utilizing the integral techniques. So here we go. So a little bit of background, what the arc length. So when you have a function, for example, let's say we have a trigonometric function such as a sine function. So there's a lot of up and down in sine function. And let's say I want to find out the length of this arc. So it's not the linear line, there's a curvy. And then I want to measure the length from A to B. How would you be able to find out the length that is not linear, right? So here is the same concept from the Riemann sum. This is the same background. Let's say I want to measure this, very up and down, curve function, and I want to measure the length. So actually, to find out the, this length, let's say we have a right triangle. So according to the Pythagorean theorem, as long as you know the length of the axis distance, and if you know the distance between two different y's points, you can find out the hypothesis, the length. So the idea is, let's say you have an infinite number of the triangle under this curve, right? So each right triangle has a different size. And then we can find out all the hypotenuse of the right triangle. So this is the hypotenuse of the first triangle. This is the second hypotenuse of the second triangle. This is another hypotenuse of the third triangle. So you have infinite number of the hypotenuse lengths of the infinite number of the triangles. So if we are able to add all the summation, if you adding all the infinite number of the hypotenuse under that curve, you can approximately estimate the curve that we are looking for. Does it make sense to you? So this is from the Riemann sum, like everything, when you're measure the area, we used to have infinite number of the rectangular, you adding all the areas of the rectangular. When you measure the volume, we adding all the same cross-sectional images of the circle. Same thing, you keep adding the same, things so that you can approximate, estimate the area, volume, or here, arc length. So one more time. So there are infinite number of the right triangle. We are keep adding hypotenuse of the right triangle. So this is the length of the hypotenuse of the right triangle. So that, because if you have a right triangle, it's easy to find out the distance between two axes. This is the distance between two y's. So that, this x squared plus y squared, that is going to be the hypotenuse square. So you're keep adding all the hypotenuse infinitely, many times. They are getting close to find out the length of the arc. Does it make sense? So that's why we are using the integral technique to find out the arc length. So here is the formula. So to find out the arc length of the curve, so let's say you have a given function. So this is the given function f of x. And let's say this curve is a continuous, there's no hole, there's no break. It is a differentiable between a and b. I want to find out the length of this arc, right? So the formula will be a little bit unique, but basically you have a interval from a to b, and then put the radical 1 plus, take the derivative of that function and the second power, and then you're going to take the integral. So that's how you can find out the arc length of the curve when the function is represented by, with y variable. Same thing, sometimes you can have the function, on the, x-axis. So there are two different functions. One is written by x variable, another one is written by y variable. Depends on the situation. You're gonna find out the arc length of the curve. So the second one is the same, but I will show you the example. Basically 1 plus the given curve function. So this is the curvy. This is the curve function will be given. And then you're gonna take the derivative and then take the square and plus 1 with the radical. And then you're gonna take the integral. You can find out the arc length of that curve. Okay, so the formula will be given. You don't need to memorize it, but I want you to guys think about why and how we can think, adding or estimate the arc length. Basically, you're keep adding infinite number of the hypotenuse. Okay, so I'm gonna show you the example. So the formula is here. I already wrote here. Okay, so there are two different formula depending on the function. If the function is solve for y, you're gonna use the first equation, and then the other case we're gonna take the second equation. So let's take a look at the question in example 1. So we are going to estimate the arc length by utilizing the integral symbol. Here we go. So find the arc length of the curve y equal to x to the third of 2 from origin 0, 0, 0, 0, to 1, 1. So let me draw that image. So if you think about the function y equal to x to third over 2, this is going to be the increasing exponent. So this is the graph of that function. So this is y equal to x to the 3 over 2. And I want to have the interval from 0, 0 to 1, 1. So basically they're looking for this arc length. We are looking for this arc length of that function. Doesn't make sense. So I want to measure this length. This is not the linear. This is a little bit of curvy, correct? So according to this formula, the function is given. So this is already written by x variable. So we're going to take the integral with respect to dx. So arc length that we are looking for from where to where? From 0 to 1 on x-axis, because we are going to take the integral with respect to x. So from 0 to 1, and then function is going to be x to the 3 over 2. You're going to take the derivative and then square and dx. This is the formula that you are going to find out the arc length of this function. So we're going to do the step by step. The f of x function is given, x to the 3 over 2. I want to find out the derivative of d over dx, x to the 3 over 2. So when you are going to solve the differentiation, this is going to be 3 over 2, x 3 over 2 minus 1, which is 3 over 2, x to the 1 over 2. So this is f prime. And then according to the formula, we are going to square of it. So this is what I'm working on. Take the derivative and you're going to do the second power. So it is going to be 3 over 2, x to the 1 over 2. You are going to take the second power. So that would be 9 over 4, x 2 to cancel. So 9 over 4, x will be the this part, correct? So let me rewrite it. From 0 to 1, 1 plus 9 over 4x, and then dx. Are you following? So we just work on this one with the second power, fx prime, and then you're gonna take the second power after to the differentiation. So now I'm gonna simplify. We're gonna find out the common denominator. 1 is the same as a 4 over 4, 9 over 4x, and dx. And then that means we can find out the common factor, 1 over 4, 4 plus 9x, correct? Because a radical with whatever the perfect square number, you can simplify, so it is going to be 1 over 2, correct? So I'm going to make a little bit of space. So that would be from 0 to 1, 1 over 2 radical will be 1 over 2, and then 4 plus 9x is still inside of the radical and dx. So this is, so we have to continue to take the integral. So I'm going to write it here. 0, 1, 1 over 2, 4 plus 9x dx. So when you look at the previous concept, this is going to be the u substitution because 4 plus 9x has been subbed into the radical function. So we're going to say let u equal to 4 plus 9x. So we're going to take the du over dx. 4 will be 0, 9x will be 9. So du will be 9 times the dx. And then I want to, right, think about, we need to solve for dx. So dx will be 1 over 9 du. Are we okay? So this is a u variation. So we used to have a 0, 1 in terms of the x variable. I'm going to convert it to the u. So u 0, 4 plus 9 times 0, 4. u1, 4 plus 9 times 1, 13. So this is a 4, 13. So at the end, this is going to be from 4 to 13, 1 over 2, radical u, and we know dx is a 1 over 9 du. Are we okay? So that's all we got. So I'm going to bring this one. I'm going to bring this one a little bit this side. So that's what happened. And then we're going to simplify. So 1 over 2 times 1 over 9. So I'm going to bring it into the front. 4 to 13, radical u du. So now we know what to do. 1 over 18, take the integral. This is going to be u to the 1 over 2. So u to the 1 over 2 plus 1 and divided by that exponent from 4 to 13. Keep going. I'm going to flip over, bring it to up. 1 over 18, 2 over 3, u 3 over 2 from 4 to 13. All right, so 9 over 1 over 9 and 1 over 3, and u 3 over 2, 4 to 13. One more time. And then we have 13 to the 3 over 2 minus 4 to the 3 over 2. So you can use a decimal, convert it to the decimal, approximately 1.439. This is the arc length, as you see in the image, from 0, 1. So this is the length we just calculated. You can estimate it. So 2.4, the arc length formula is a given. And then we know how this formula is, created. We are keep adding the hypotenuse infinitely under the curve so that we can estimate the arc length. So that you can find out the answer like that. Okay, so 2.4 is not really complicated concept because the formula is a given and then we know how to take the integral, so it should be fine. Okay, I'm gonna practice a couple more example. Okay, so let's take a look at a couple more. So I'm gonna go down slowly and surely. So always you can pause the video. You can take enough time to take a note. so that, that's no problem. So that's why I'm recording all the videos. So let's take a look at example 2. Okay, let's check it out. What is going on? I'm going to find out the arc lengths of the following function from 0 to 1. So same idea. We have 2. So this is another curve function. Y equal to 2 times x to the 3 over 2. And they're looking for 0 to 1, this arc length. Are we okay with that? So this is going to be the x variable. So f of x is a given. 2x 3 over 2. And arc length we are looking for from 0 to 1, a to b, but we know it's a 0 to 1. And then the formula said radical 1 plus f of x, take the derivative, and then you're going to take the square and dx. We're going to use this formula. So in order to do this, we're going to find out what the f prime d over dx 2x 3 over 2. So if we are working on it, this is going to be 2 times 3 over 2. X 3 over 2 minus 1, cancel. 3x 1 over 2. And we are going to square of it. So 3x 1 over 2. Second power. 9 cancel x. So we got this is going to be 9x. I'm going to bring this one a little bit here. So we have all the f, and then we're going to use this formula to find out the arc length. So this is something we got. And now let me rewrite it. So this is going to be from 0 to 1, 1 plus 9x dx. Are we better? So what are you guys going to do? This is another u substitution. So we're going to take this, let u 1 plus 9x du over dx, that is 9. So dx will be, what do you guys think? Dx will be 1 over 9 du. So we can substitute in terms of the u variable, and 0, 1, this is going to be in terms of the u variable. So u 0, 1 plus 9 times 0, it's going to be 1. U and 1 plus 9 is going to be 10. So 1, 10, this is going to be the interval in terms of the u variable. So anyway, we have from 1 to 10. Now u dx is 1 over 9 du. So it is going to be 1 over 9, 1 to 10, radical u du. So take the integral. So this means 1 over 9, 0, 10. Oh, my bad. It's not 0, 10, 1 to 10. So let me rewrite it. 1 to 10. U to the 1 over 2 du. And then 1 over 9. U 1 over 2 plus 1 divided by 3 over 2 from 1 to 10. Are we following? So let me minimize a little bit because I need a space. I'm going to flip this one. So 1 over 9 times 2 over 3. And then we have u to the 3 over 2 from 1 to 10. So this is going to be 2 over 27. And then 10 to the 3 over 2 minus 1 to the 3 over 2. Again, you can use a decimal. You will get this decimal about 0.2697. That is the arc length of this function from 0 to 1. So we just evaluate the green line. Okay. How you feel? It's getting better and better, right? So again, 2.4, it's a fun topic. We are just looking at another perspective of utilizing integral. It helps us to find out a lot of information, area, volume, arc length, and I will introduce later surface area. But before we're going to get there, I'm going to talk about 2 more examples. Okay, example 3 and 4. So let's go down slowly. So I want to give you guys a little bit of time. So later you can use a decimal to simplify the answer. But here, this is a little bit tricky question. So let's think about it. So we're gonna measure, we're gonna estimate the arc length. And the function is a sine. So the sine function, we know y equal to sine x. If you go to decimal, it looks like that. Up and down, every 2 pi. Right? This is a sine function. And then they're looking for, between 0 to pi. So this is a pi. They're looking for the arc length. This arc length of the sine function, 0 to pi. We got it, right? So this is the sine x. So we know this is f of x equal to sine x in terms of the x variable. So according to the arc length formula, we can set it up from 0 to pi. You're going to find out what the f prime to the second power. And then we're going to take the integral. So let's take a look at it. F prime x d over dx sine x. When you take the derivative of the sine x, that is a cosine x. And then I'm going to square of it. That's going to be cosine second x. So we have those are three. So this is going to be cosine second x. So 0 to pi, 1 plus cosine second x dx. Are you guys okay with that? And then here, you can do, a lot of work, but it's going to be very complicated. I will show you a little bit of tip. So you can actually use decimal directly because of 1 plus cosine second x. We know that cosine second x plus sine second x is 1. So 1, we know that cosine second x is going to be 1 minus sine second x, so that you can actually keep going this work, but it's going to be a little bit complicated when you're substitute the u substitution. So what I'm going to do, we can directly plugging in this information into decimal. So I will show you a little bit of, technique how to use a decimal. So if you go to decimal, so let me go to decimal here. They help us a little bit if we have a complicated function. So there's I'm going to type integral. So when you type int, they automatically change that to integral symbol. So, and then we know from 0 to, and then this is going to be pi. And then we have radical 1 plus, and then we do have cosine second power. So cosine x to the second power, and then we are going to take the derivative dx. So when you type that information, they're going to calculate the integral, with the decimal. It's 3.8201. So that's actually our answer, 3.82. So this is simply, we can calculate it, 3.82. That's the arc length from 0 to pi of the sine x function. The reason why I'm using decimal, because it is a little bit complicated, very, very complicated function. Use substitution, it's definitely complicated. You can try, but sometimes using decimal also helpful. So check it out. But other question, I really want to see all your work, right? You can show me all your work without using decimal. Okay, so think about it, just a little bit of tip. So that's the arc length, and I will do one more example. So similar question here. All right, let's take a look at it. Now we have the gy function. So calculate the arc length of gy function between 1 to 2, okay? So if you go up, do you remember we have a 2 arc length formula? One is in terms of the x, another one is in terms of y. Same thing, same formula. So we're gonna take the derivative of the gy and then take the second power. And then you're going to take the integral with respect to y. That's only the different thing. It's the same. But depending on the function, you have to read the question, whether it is the f of x function or whether it is a written y variable function. So when you get that, you can see the difference. So anyway, here, arc length, we're going to use a CND, 1 plus gy derivative and second power, and then dy. So we have every information here. Gy is a 3y to the third, g prime y, 9y to the second power, and then you are going to square of it, 9y second square, 81y to the 4, and you can plugging in, and then you can finish up the work, right? So try this one, and then from 1 to 2, 1 plus 81 y to the 4 and dy. Okay, so you can continue. You can factor out 81. So what I'm saying is 1 to 2. This is the same as 1 over 81, 81 plus y to the second dy, because I can factor out 1 over 81. So when you do the distributive property, actually, I have a little bit of typo. So let me change this. You're going to factor out 1 over 81. Then this is going to be, let's factor out 81. So 81. Then this is going to be 1 over 81. And then this is y to the 4th. That's better, right? So 81, radical 81 become 9. So 9, we have a 1 over 81 plus y to the 4 dy. So you can use a u substitution here, or you can use the, do you remember inverse trigonometric sub? This is a perfect square, a square plus x square. So you can utilize inverse trigonometric sub, or you can use u substitution. You will get the same answer. So this one, I will leave it for you to try. So try the rest of work. This one might be in the next test. That's why I want you guys to try. But same thing. This is, we are looking for the arc length, gy. So it doesn't matter. You know, the formula is the same thing, whether it is related to the x variable or y variable, so that you can think about those three and then evaluate what the gy, prime and second power. And then the next work, you have to think about it. We learn all integrals techniques. So this is the thing you're going to continue. You can use either u substitution or inverse trigonometric sub. So when you have this format, right, you remember you're going to say, I think a times like sine x. You're going to set it up u equal to that way and then check. So this is I think chapter 3.3, check it out. And you can check u substitution from chapter 3.1. So go back, you can use either one, they're gonna give you the same answer. So try how to find out the outcome of this integral. So this is, I'm gonna highlight it. And then you will get the answer. So try the rest of work. Okay, so I'm gonna just make a little bit of space, because we talk about a lot of things about integral. So let me just write something. Integral. This guy, we are writing with this symbol, a to b, f of x dx. This came from the Riemann sum, right? So whatever you have a given area or a given image, you keep adding them. And then from the whatever the given, so this is a Riemann sum. And in modern mathematics, we are using the integral symbol. So far, we talked about a lot. It helped us to find out area under the curve, right? So that was all about chapter 1 and 3. We talk about many integral techniques. So when you have composition function, we use a substitution method. If you have whatever the given function, you're going to use this technique. So there are many techniques in terms of integral to find out the area. And then in chapter 2, integral also help us to find out the volume. 2.1, 2.2, 2.3. So there was a disk method, washer method, or shell method. Check it out, right? And then depending on, you are looking for the cross-sectional image, right? And then adding, so you can find out the cylinder. Or if you have a two function, we're going to use the washer method. So there's a hole. The shell method, you can find out the cylinder, and then you keep adding all the surface, the shells, and then you can find out the volume of entire shells. So that was a volume. We've been utilizing the integral. Here, 2.4, we were able to find out the arc length as well by using the integral. So you can have a very up and down curve shape. You can find out this length, although it is not a linear, by using the formula we are given. Last thing, 2.4, we are also able to find out the surface area by using the integral symbol. So that's something I'm going to talk about right now. So think about this concept, man. Integral is a wonderful and powerful tool. That's why. So let me show you how we can find out the surface area using integral techniques. So here we go. Okay, so far, we were able to find out the arc length, right? So let's say you have curve here, you have a curve, right? And then this is the function, let's say f of x. So to find out the length of this arc, we were able to use this formula, integral. Am I correct? But now let's say you are going to rotate this function about x-axis, and this is a 3D dimensional space. So I want to find out the surface area. So you have to think about it. This is not really cylinder. This is a little bit of different shape. So there's a curve. There's a curve. And I want to find out the surface area of this shape. Number one, what we know how to find out this, right? So according to the formula, if you are multiply 2 pi r, 2 pi times r, this is the height. This is your arc length. What do you think? Arc length times 2 pi r, you can find out the surface area. So this is the formula when you're rotate the function about x-axis. Everything is in terms of the x variable. Same thing, you will get another function is about like you have another function, right? Something here. This is on the y-axis. So this is going to be written by y variable. You can find out the surface area because this is the height times 2 pi r. And then here 2 pi r, and then you're going to keep the same arc length function. And then take the derivative with y variable. This is arc length formula when you're rotated about y-axis. So finding surface area is not that difficult. So surface area, right? This is a circumference times height. So circumference, this is a 2 pi r. And then height, this is your arc length. Am I right? So this is a circumference 2 pi r times height, which is arc length. That's what we are doing. Arc length height times circumference area. And then take the integral from whatever a to b, you can find out the surface area. This is when you're rotated x-axis. Same thing, you can find out the surface area, 2 pi r times the height around you're rotating about y-axis. So same thing you can do in terms of the y variable. So what do you guys think? very similar what we did in arc length. So let's take a look at the example. I'm going to show you here. So I have two formula here. Let's find out the surface area when you have this given function from 1 to 4. Okay, they're going to rotate it x-axis. So if I draw that image, this is y equal to radical x, and I'm going to rotate this function about x-axis, exactly at x-axis, and then from 1 to 4. So the image is going to be something like that. I'm looking for the surface area of this shape. So what do you guys think? You're going to find out 2 pi r, the circumference, times the height, which means 2 pi r times arc length, so that you can find out surface area. So the formula is given, and then this is about x-axis. You're going to take the integral with respect to x variable. Gotcha. So surface area from 1 to 4, 2 pi, f of x function is a given, times the radical x, and then you're going to find out 1 plus f prime x second power dx. So one more time, this is the circumference 2 pi r, and then this is the height. So exactly, we're using the surface area formula. So let's find out. F of x was radical x, which means x to the 1 over 2. F prime x is a 1 over 2, x to the negative 1 over 2, correct? And I'm going to take the second power. So it would be 1 over 4. And then you're going to multiply 2, x to the negative 1. So that means 1 over 4x, we got it. So let me just minimize a little bit. So this one, I'm going to bring this one here, and I'm going to bring this one to the left side. So we got it. So let's plugging in from 1 to 4, 2 pi. And then we have a radical x. 1 plus, we got 1 over 4 x dx. And then this is the same radical. Let me combine it. I'm going to bring it inside. So x times 1 plus 1 over 4x dx. And then that is 1 to 4, 2 pi, x plus, what do you guys think? X and x cancel, 1 over 4 dx. So here, I feel like we're going to use a u substitution. So we're going to say u equal to x plus 1 over 4. du over dx is 1. Are we okay? And then we're going to change 1,4 in terms of the u variable. So u1 equal to 1 plus 1 over 4, 5 over 4. u4, it is going to be 1 plus, actually 4 plus 1 over 4, 17 over 4. So if you write that, it is going to be from 5 over 4, comma 17 over 4. So let's rewrite that equation. So we have now 5 over 4 to 17 over 4, 2 pi. And then now that is u, and dx is a du, right? dx is a du right there. So I'm going to bring 2 pi, that is a constant, to the front. So 2 pi. And then we're going to take the integral. So before we're going to get there, 5 over 4, 17 over 4, u to the 1 over 2 du, 2 pi, 5 over 4, 17 over 4. Oh, actually, we can take the integral. So u, 1 over 2 plus 1 over 3 over u, 3 over 2, 5 over 4 to 17 over 4. Got you? And I can flip over 2 over 3. And u to the 3 over 2, 5 over 4 to 17 over 4, almost 4 pi over 3. And then I just combine this two. 73 over 2, actually my bad, 17 over 4 to the 3 over 2 minus 5 over 4 to the 3 over 2. So now you can put this equation into decimal so that the surface area approximately 30.846. That's your answer. So nothing is very special here. We know how to find out the height, the arc length. The formula times 2 pi r. Right? The height gives you the radius of the circle. So you can find out the circumference, 2 pi r, and then using the integral technique here, use substitution, you can find out the surface area. That's pretty much it. Okay. So likewise, I'm going to just do 2 more questions so that you can practice more and more with me. So let me just go to the next question quickly. So here we go. So we're going to find out what surface area with this function from 0 to 2. Whoa. We are going to rotate it about y-axis. So if you remember, surface area from C to D, 2 pi. So now this is going to be f of y because we are rotating it y-axis. Everything is in terms of the y, so y prime, second power dy. We are rotated x-axis, correct? So one more time, this is the 2 pi r. This is the height, the arc length. So let's just set it up. But here, the function is given in terms of the x. So 3 radical 3x. This means 3x to the 1 over 3. I want to convert it to the fy function. So what we're going to do, we're going to solve for y, correct? So we are going to convert it. So this means y equal to now 3x to the 1 over 3. Let's say we're going to solve for, actually we're going to solve for the opposite x. So if you multiply 3, y to the third, it's going to be canceled, 3x. You're going to divide it by 3, y third over 3, that is x. So we have f of y is y to the third over 3. So this is what we are going to use it in terms of y variable, correct? So to put it here, we need to evaluate what the y prime y first. So 1 over 3, bring 3, y 3 minus 1, so cancel y to the second. That's a y prime. And then you are going to square of it, y to the second, it's going to be y to the fourth. So we have all those 3 information. Then what are you going to do? We're going to plugging into the formula. So surface area from 0 to 2, correct? And then what are you guys going to do? 2 pi. Fy is y to the third over 3 plus 1 plus y to the 4. We just evaluated dy. So now again, I can simplify. I'm going to bring the constant 2 pi over 3, 0 to 2, y to the third, 1 plus y to the 4 dy. I see the u substitution. So we're going to say let u 1 plus y to the 4 du over dy. It's going to be 4y to the third du equal to 4y to the third dy. And then I see that I want to find out what the y third times the dy. So we can modify this. First, I'm going to divide it by 4. So that would be du over 4 y to the third du because the 4 cancel. And then you're going to multiply 3. Oh, actually, we don't need to do anything because we already found out what the y third dy, that is 1 over 4 du. Again, 0, 2, that is going to be converted in terms of the u variable. So u0, it's going to be 1. u2, when you're plugging in, 1 plus 16, 17. So 1, 17, that is your interval in terms of u variable. So now this one, 2 pi over 3 from 1 to 17. And now we have a radical u, y third dy, that is 1 over 4 du. So again, 2 pi over 3 times 1 over 4, 1 to 17 radical u du. Better? So therefore, I can simplify. It's going to be pi over 6. And then u, 1 over 2 plus 1 divided by 3 over 2 from 1 to 17. So pi over 6, you can flip over 2 over 3, u to the 3 over 2, 1 to 17. Cancel. Pi over 9. My calculation fine, right? And then 17, 3 over 2 minus 1 to the 3 over 2. Again, go to decimal. You can find out the decimal, 24.18. That's the surface area of that function when you're rotated about y-axis. Better? So definitely you can do this question. Nothing is complicated. You can do it, right? So let's finalize the next question. It's the same thing. I'm gonna just set up the equation and then you're gonna do the rest of work. This is the same thing. They're rotating, the function is a given. They're rotating it about x-axis. And then when you're rotating x-axis, the interval is gonna be 1 to 4, right? So from 1 to 4, right? So how to set up that equation? Same thing, surface area, right? A to B, but in this time we have 1 to 4, and that's their rotating x. And then 1 plus f of x prime, second power dx. So you're gonna, this is a surface area formula? No, this is arc length. So you have to multiply 2 pi f of x. That's a 2 pi r. So let's plugging in. First, we need to find out, okay, f of x is already radical x. Thank you. We don't need to convert anything. F prime. So this is x to the 1 over 2. So you have a 1 over 2, negative 1 over 2. F prime, and we are going to second power 1 over 4x to the negative 1, which means 1 over 4x. Correct? So you can set it up, this equation, everything now. So now 1 to 4, 2 pi. I'm going to bring 2 pi to the front. And then f of x, we have x to the 1 over 2, which means radical x. And then we found out this part, 1 over 4x dx. We did the similar question, don't you remember? And then I'm going to combine this two, 2 pi, 1 to 4, entire radical, x 1 plus 1 over 4x dx. So now 2 pi, 1 to 4, it means x plus 1 over 4 dx. We did the similar question. So now I'm gonna copy this. You are going to say, use substitution right there, x plus 1 over 4, and then you can finalize whatever the answer, continue. We did the same question above, so check it out. You can finish up the rest of work yourself. Try. Okay. So check all the questions. We introduced how to find out the arc length in 2.4. We utilized the integral symbol to find out the arc length. And we also able to find out the surface area. So depending on the function, we have a 2 function for each. So organize it. And then, you know, we can find out many things by using the lemma sum. Okay, so that's a pretty much 2.4. Now you can finish all the questions and quiz. There are embedded video, you can watch more. So feel free to, you know, study with them. And then if you have any question, email me. So in the next video, we're gonna move to 2.5, very short topic. And I will see you in the next video. Thank you, everyone. Bye-bye.